Yeah, there's paper 1 and paper 2.
Anyone else?
At the start of class, I passed out you guys a copy of the formula book that you would have gotten. I don't remember what year this would have been from. I didn't imagine the formula book has changed much. I think this is from 2021. But this would be the kind of the formula book format that you would have gotten with your exam. I think I asked you guys to skip, what were the 2 numbers, or the 3 numbers, like 6, 9, and 11. Great, thank you. So again, if you haven't, if you weren't here on Monday and you didn't start on this, I would find a little bit of time and work on those. Again, you should skip 6, 9, and 11 as it's containing topics we haven't covered yet. You have the equation sheet now with you. That'll be how the IB would format their equation sheet. So anything given in there would be something you'd expect to get when it's your time to do it. I think it kind of helps to have that as to practice with. Notice that it's got stuff that it'll be of no relevance to because it contains HL formulas also. So you have to make sure you're kind of reading appropriately and looking at what you have. So I think having a little bit of practice time on it is helpful. We'll circle back here in the coming days and spend a little bit of time talking about some of the problems from this practice test that I gave you guys. But I don't want to do that right now. Is that okay with everybody? So again, kind of continue picking away at things as you're able to find some time. It's not a rush, it's not an assignment. It's purely for enrichment for you to kind of get some practice and get familiarized with kind of what the format of the test is going to look like and what the test questions will sound like and how the IB asks for things and raises questions and get you some practice using the equation sheet. Some of us care deeply about our IB scores because we have a diploma we're shooting for, and some of us are, try to do okay, but I'm not too worried about it. But again, trying to be respectful of people in either position. Okay? Questions about any of that stuff so far? Gonna take a minute, pass back the chapter 3 test that you guys took before break. So I ended up, I noticed that I forgot to do something with you guys for this test, so I ended up throwing out a couple of questions. We'll talk about that here in a minute.
But I want to.
Can I go to the back?
Yeah, exactly. So there's no point. It's excuse that.
All right. So if you take a look at your look at your tests. I ended up throwing out questions 9 and 14 as we didn't have, I forgot to cover something I should have. Because for whatever reason, that page I lost in my OneNote outline. So we're gonna do that now, talk about that. So those 2 questions did not hurt you. What?
Did it help?
No, I just didn't count for anybody. So what we didn't spend enough time, or didn't spend any time talking about, was using a specific function on our calculator called the Finance app. And that makes dealing with some of these questions, specifically like things like 9 and 14, considerably easier. So I want to spend a few minutes here kind of talking about that. Sound good to you guys? If you have a calculator with you and you'd like to follow along, I encourage you to take that out. I have a couple on my desk. If you forgot one and would like to borrow one so you can follow along also, you're welcome to walk on up and grab one off my desk, no big deal. Okay. So what we're gonna do is we're gonna start by pressing the Apps button on our calculator, which for me is just kind of right in the middle there. And everybody should have the Finance app as an option. You see option 1 on my calculator says Finance. Even if you don't have all the other things that I have on there, you should have the Finance app. So let's select that. And the one that we're going to choose to use is the TVM solver, the first option. That's the one we're going to be using. So any of these finance-related questions that we've encountered can be solved using this tool. Everybody's okay? So I've just stolen a few questions from the test homework. We're going to kind of go through how I can use this Finance app to answer those kinds of questions. Everybody sound good? It says at the beginning of every month, Maggie invests £150 in an account that pays 6% annual interest. How much money will be in the account after 6 years? Okay. So let's start filling things in. So it should be pretty clear that the interest rate is 6. Notice there's a percentage symbol next to it, so it wants us to write the interest rate as a percentage, not as a decimal. PV stands for present value. How much money was in this account when we started? 0. 0 in, right? But she's making a payment, right? What is she doing? $150 every month. Now, is that $150 going into her pocket or out of her pocket? Out. So we're going to have like some negative signs in here to indicate some flow of income. So I'm going to write this as negative 150 to indicate that that money is leaving whoever this girl's name is. I forget what was her name. Maggie. Leaving Maggie's pocket and going into the bank. Everybody's okay so far? P/Y stands for payments per year. How many payments is Maggie going to make in a year? 12, because she's doing this every month. Now, if you make 12 payments per year, the compounding has to happen 12 times per year. Those two things are fixed and they're going to change automatically. C/Y stands for compounds per year. Everybody okay? The last thing I need is my capital N. What does my capital N need to be? because
6 years.
6 years, it's not 6, but the 6 years is a factor. It's going to be, the N needs to be the total number of compounds that happens, or the total number of payments that happens. So it's going to be 12 times 6. Or 72, really. But you can just write it as 12 times 6 and press enter. And the calculator will just handle this for us. And which quantity are we looking for now? The future value, right? That's what we want to know. So to get the future value to come out, I'm going to move my cursor so that it's on the 0 for future value. And then I'm going to press alpha. And then enter.
Oh.
And boom, there it is. So notice that this is a positive number because now this future value, this money that's in the bank, is now going to come back into Maggie's pocket, right? Now, if you screw up the signs, it usually isn't a big deal. Just keep in mind that, like, the number at the end should be a positive number because we're talking about monies. But does everybody feel okay? Let's do another then, yes? In particular, this is super useful for these ones where we're like making payments or calculating how much a payment needs to be or things like that. So it says each month Suzanne invests 100 euros in an account earning 4% annual interest compounded monthly. Find the value of the investment after 20 years, assuming she started with a 0 balance. And then how much initial balance would she have to have had at the start if she makes no monthly payments, but the account has the same amount of money as your answer to part A. So let's do part A first. So let's fill this in. What is my N going to be?
12 times, I think it is,
20. We're doing this for 20 years. How about my I?
4.
That was 4. The present value should be
0.
0. Let's do this. Okay. The PMT should be negative 100. The future value is what we're looking for, so that can just stay what the number it is. And the payments per year should be, and the compounds per year should be 12. So to get my future value, what do I move my cursor onto the future value, and then what do I press? Alpha enter. So $36,677.46. Everybody feel okay with what we did? Basically the same process as last year, right? Or last question. For part B, though, we asked something different. We asked, okay, let's say I want to end up with the same amount of money, this $36,677.46, but I don't want to make any payments, right? I want to just put an initial investment in and get that same thing coming out, right? So my payments I'm going to change to be 0. And the present value is what I want to actually calculate, right? So once my cursor's on PV, I can press alpha and then enter. And it tells me I would have had to deposit $16,502 and, 19 cents or whatever. Is everybody okay? And the negative sign there is because that money would be leaving Maggie's possession right? Does that feel okay? Yeah, Brooklyn?
Everyone.
Okay.
When I tried to do the payments for your make it 0, it's giving me an error.
What does the error say?
This is error domain.
That's odd. I'd have to look at it specifically. We can talk after. Okay. I think I got another couple in here. So the next one says, each month Maxine invests £150 in a fund for her retirement. The fund earns 6% annual interest compounded monthly. Find the value of her retirement fund in 30 years. Okay. So my N should be,
360.
yep, 30 times 12. And I always write this as the multiplication problem just so I don't have to trust my mental math. Especially at 8 o'clock in the morning, that's always a dicey proposition. My I should be 6. My present value should be 0. My PMT should be
Negative 150.
good, negative 150. And we're looking for the future value. And my compounds per year and payments per year should both be 12 still, so. Old Maxine would have $150,677.26 or something. Okay. What if she saved $200 a month instead, is what part B says. So ends up with 50,000 extra bucks. Yes? Sure. Does everybody feel okay here? Okay. The next one says, find the monthly payment required to save $4,000 when earning 4% annual interest, compounded monthly within 5 years. Okay. So here we're asked to solve for the monthly payment, right? This initial setups and everything is still going to be the same. My value for N should be 5 times 12. My I should be 4. The present value should be 0, right? We don't say we're starting with anything. The PMT is what we're solving for. The future value should be 4,000. And we're doing this 12 times per year, compounding and payment, right? So I'll go up to my payment then and press alpha and enter. So we'd end up needing to save $60.33-ish cents or 34 cents. Probably want to round that up so you know you're north of 4,000. Everybody feel okay here? Notice that kind of no matter what the question is asking for, this TVM solver can just, you put the inputs in the right spots and you just doodly-doo, and it spits out your answer, and it's easy peasy, and no need for formulas to do this. And again, this would be something that you would be expected to be using on your IB exam to do questions like this. They expect you to be using this calculator tool. All right, 13 says a loan takes 10 years to repay at $450 per month. The annual interest rate of the loan is 5%, and the loan is compounded monthly. Find the initial value of the loan. So again, start by finding my N, which is just going to be the length of the loan times the number of payments per year. The I is clearly 5. The payment we're making is $450. Oops, let's make that negative. So we're paying that out. Oh, sorry, that's the present value. That's what we're looking for. The payment, that's what I meant to put the negative 450 in. The future value. So how much did we end up paying here? 10 times 12 times 450, right? For 10 years, every month we paid $450. That's how much we paid back to the bank. What we want to find out is how much we initially borrowed, right? And actually, I'm going to make that negative because, again, that's money we paid out, right? So then I'll press on present value alpha enter, means we'd have borrowed $75,213.31-ish cents. Does that feel okay with you guys? So again, if you're looking for how much you borrowed, that's going to be a present value. The total that you ended up paying for the loan, that would be like your future value. Everybody okay with how we calculated that? Part B says calculate how long it would take to repay the loan at $900 per month. Oops. Wait a minute. I couldn't have done that last problem right. How come nobody yelled at me? Huh? Where are you guys' heads at? Who? Look at these. Look at the stuffs here. Oops. Oh, okay. That's now a reasonable number. No, that's still not reasonable. What did I do before?
Negative.
Okay, that negative. Yeah. So how do I know that this is a nonsense? How do I know that like I got this answer and it's that cannot be correct? This bank would be going out of business. This is the correct answer. Because you're telling me that I borrowed $75,000 and only paid back $54,000, and that was my loan, right? What bank is going to stay in business doing this? Yeah, nobody. No bank is going to say it. So we did something wrong here. Let's take a minute and think about this. Okay, this is, I think, how I need to format it. So I received that looks right now. Why is the future value 0? What are we doing in this problem? We're paying back a loan, right?
Oh, so we have one.
So at the end of the loan, your balance with the bank should be
0.
you owe them 0, right? So how much did I have to start with that I paid $450 every year at 5% interest to get me back down to 0? That's $42,000, which should make sense because we ended up paying $54,000 for the loan. That makes sense. That tracks. Those numbers jive with me. So again, everybody's okay there? So loans should be ending in 0 because you pay back. Apologies on the stumbling through that. Says, how long is it going to take to pay this if I'm doing $900 a month instead of $450? So it'd be like 53 months. Again, I'm still borrowing that same amount, still borrowing that $42,000 and change, but this time I'm paying $900 a month instead of $450. Notice before it was taking me like 120 months to pay it back. Here I did it in under 60. I paid twice as much, but finished in less than half the time. Because less interest is accumulating, it's taking me less time to pay it off. And notice here that I'll pay much less for the loan in totality, right? If I do 52.6 times 900, that's going to be way less than the 54,000 that I would have paid initially for the other circumstance. Is everybody okay with what we did there? I think this is my last example that I pulled. Every month since her 12th birthday, Hannah has deposited $200 in a bank account, earning 6.2% interest, compounded monthly. And if Hannah just had her 32nd birthday, how much money is in the account? When Hannah turns 40, she doubles the amount of money invested. How much money to the nearest 1,000 will she have when she retires at 65? Okay. So the hardest part about this problem is getting the end correct. So I'm going to actually write a little bit here to kind of illustrate how I'm going to do the counting. So when we're 12-year-old, so this is our birth month, right? At 12 years old, so we did nothing on our 12-year-old birthday because it says since her 12-year-old birthday, right? So then we had $200 in month 2. Actually, let's do this January, February, March, April, May, June, July, August, September, October, November, December. Everybody's okay? So that first year she made how many payments of $200? 11, right? Now year 13, when we're 13 years old, we make 12 payments, right? And that's the same thing all the way up to just had her 32nd birthday. So 12 to 31, we made 12 payments, right? And then when we turned 32, we just had it. So I think we made that one more payment. It's okay. So from 13 to 31, how many payments did we make? Right? Year 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. That should have been 19. Everybody's okay there? And then we have another 11 here and 1 down here. So basically, my n should be 20 times 12. Everybody okay? So again, you have to be careful because of the time piece of this, which is like really aggravating and kind of annoying, but like that's what that's the trick. And then it was 6 point something. 2?
2.
And we start out with nada. And we're paying in $200. What? That. That's okay. So I think that's probably our answer for part A. For part B says when we turn 40, then we double the amount of money invested. So our payment once we turn 40 is going to be $400, right? So then at like, let's do to 39, we have that. And then at 40, we're going to double it. Is everybody okay here? Notice what happened here though is now we don't have an even number of years of paying $200. So year 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, so 27. And then we have 11 up here. And then down here we have 40, 41, 42, 43, oops. But this is really only going up to 64, right? Because once we hit 65, we're retired and we're stopping doing that. Okay, so 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 60, 1, 2, 3, 4. So 25. Is everybody okay with that? All right. So how am I going to handle this if I have like I guess I should do that. All right, I'm just going to do part B. So how am I going to handle this, doing this in 2 stages? Where the payment is changing halfway through. Well, I'm going to do it as like 2 steps. So I have 27 times 12 plus 11. So that's the compounds that are happening at $200. Everybody's okay there? I'm going to then transfer that as like my initial amount. Move my payment to $200. And then this needs to be 25 times 12. Is everybody okay with that? So this is the 178,000 is like how much I saved to age 40, in which case my payment changed. So I'm just going to now do a second calculation. Oopsie daisy. I need a negative sign in here, or else things are going to get all wonky on me. There we go. So it looks like $1,125,500 or $171.27 or something. So you want to grow up and be a millionaire. This is the ticket. Like a pretty sensible investment done early enough and made consistently. You too will be a millionaire one day. Index fund is probably all you need. In fact, I would assume like just buying S&P 500 shares or Dow shares and NASDAQ shares, just index fund shares are going to do better than 6.2% over the long term. I think those will be closer to 7 or 8. And you have a little bit of catching up to do because you're 16, 17, 18 years old right now, maybe 19, somebody in here. So start saving. $200 a month, up to $400 a month, and you're retiring a millionaire. It's a pretty good deal. Do we feel comfortable using this finance app? My apologies for not remembering to do that in advance. I think I took off. The questions were like feasibly calculating a payment is not simple without the finance app. So I took out the questions where I asked you to do that. You should have still been able to use the compound interest formula to do the other ones in there. Even without the finance app, although the finance app makes that a lot easier. Okay. Everybody good? Okay. Let's start chapter 9 then. We'll talk about this for a little bit. So chapters 9 and 10 we're going to kind of do together as one test. We'll do 2 quizzes. I'll do a quiz after chapter 9. We'll do that as like a take-home or whatever, and then I'll start chapter 10 and we'll do a chapter 10 quiz and a chapter 10 test as usual. Mostly because you can't do anything from chapter 10 without chapter 9 in it already.
Wait, chapter 9 and 10 test or just chapter 10 test?
Yes.
Okay.
Like everything we're doing in chapter 9, you need to have to do anything in chapter 10.
Okay.
So like all the skills from chapter 9 are necessary skills from chapter 10.
Yeah.
So like I can't,
I see what you mean.
there's no way to actually separate
I see what you mean. Yeah.
and do a chapter 10 test only because it uses all the skills from chapter 9 to do it.
Okay.
You get what I'm saying?
Yeah.
So, chapters 9, 10, 11 are our calculus chapters. So this is our, super diet soda version of calculus you're going to get. So this should be new to everybody in this room. So if you are not really paying attention, you might want to tune in for this one because it's something that I don't think any of us have done. I mean, Blake had 3 days of calculus or whatever before he's like, I have enough of this. This will not be nearly as difficult as the AP calculus version. So what we want to do is we want to start by talking about average rate of change. How many of us are in a physics class right now? Excellent. When you talk about average rate of change, you're just talking about distance divided by time, right? Or a slope, sure. So if you go 100 miles in 2 hours, our average rate of change would be 50 miles per hour, right? Wow. Notice that we're getting a rate back from that. Our average rate of change should be a rate like miles per hour. What if we have the function y equals x squared plus 2x plus 3 on the interval from 0 to 3? What would be the average rate of change for that? Is everybody okay with this abbreviation for average rate of change? Okay. I didn't say that's what that was, but I should mention that. So how am I going to do this? Well, I'm going to have the change in y's divided by the change in x, right? So when I plug 3 in, I have 9 plus 6, that's 15, plus 3, that's 8. And then minus, when I plug 0 in, I get 0 plus 3. And again, notice that this is just slope, right? Where you have the point like 0, comma, y0, that's like my x1 and y1, and the point 3, comma, y of 3, that's like my x2, comma, y2. Everybody feel okay here? We're just basically calculating a slope. When you hear average rate of change, we're thinking slope formula. What if I want an instantaneous rate of change? Right? So like, you're driving your car, right? You get in your car, you turn it on, you back out of the driveway, the speedometer goes up and then down because you have to come to a stop. You put the car into drive, you speed back up. You know, like you come to a stop sign, you slow down and you stop, make your turn, you get onto a busier road, so you speed up faster, trying to pass somebody, you speed up a little more to get in front of them. You come to a stoplight, you slow down, you stop. You know, you turn and get on the freeway and you really speed up, and then there's an accident up ahead and you all have to slow down and inch along for a while. So you go 100 miles, it takes you 2 hours to get there. Were you going 50 miles per hour? Maybe at some instant along the way you were, but for most of the drive, your speed is going up and down and up and down and up and down all over the place, right? Now, if you're driving along in your car and you look down at the console on your car, what are you going to see on there? You see the speedometer is going to show you a number, right? It's essentially going to give you your instantaneous speed at that moment, right? Now, your car is able to calculate that by measuring like how fast the wheels are spinning and knowing how big the wheels are and all these things, right? But we might desire to have the instantaneous rate of change on something that's where we can't measure that easily. So imagine I'm just, I take an object and I drop it, and I want to know how fast it's moving after a second, right? Now, that's not easy to measure because there's no, spinning wheels to measure, how fast this thing is spinning. I can't do that instantaneously via measurement. But that is something that I'm going to want. So let's say we have some function. Our function y equals, we'll use the same function, y equals x squared plus 2x plus 3. And we want to know the instantaneous rate of change at x equals 2. So essentially I'm asking for a slope of this function, but using one point. What happens if I try to use the same point twice in the slope formula? What am I going to get? I'm going to get 0 over 0, right? If I use the same point 2 times in the slope formula. What's 0 over 0? It's not 0.
1.
It's not 1. It's worse than undefined. It's something called indeterminate. So indeterminate is worse than undefined. 2 over 0 is undefined. That just means it's going to infinity or negative infinity.
Yeah.
0 over 0 is indeterminate in that you can't even say it's doing that. I could write you an expression that simplifies down to 0 over 0 that could be 1, could equal 1, could equal 2, could equal 3, could equal anything you want it to. Yeah. So what are we going to do as our workaround? Well, let's think about this graphically for a moment. So let's say that here's the graph of that function. And I'm interested in the slope of this function at the instant where x is equal to -2, right? So there's -2. So basically I'm looking for this line that's going to be tangent to the curve. So my instantaneous rate of change should be the same as that slope of our tangent line. You guys okay with that? Now, how am I going to come up with that? Right? That's just like, okay, same problem, Mr. Kulik. I don't know, I don't have any other points on that line. How am I going to calculate the slope of that thing? Well, here's what we're going to do. Or here's what we do. So what we're going to do is we're going to look at we have the point -2, 0, that's on our line. And we're going to pick a point on the curve that's just like a little bit away. So I'm going to pick some curve that's like h units away. Right? So it's just going to be like -2, plus some h. Right, okay? And now that I have 2 points, I can calculate a slope of that line. Everybody's okay with that? And then what I do is I keep picking that h so that that h is closer and closer and closer and closer to 0. And I look at what's going to happen. So maybe I start with 1, and then I try 0.1, and then 0.01, and 0.001. Look at what's happening to our slope of our line as those 2 points get closer and closer and closer together. I can't make them actually ever equal because then I get 0 over 0 and it breaks. Is that okay with everybody? So I'm going to take out my graphing calculator to kind of show this. So I'm going to do this in maybe the most convenient way I know how. So into the y equals, I'm going to type in the function that I'm looking at, right? And I want the fraction. And I'm going to do vars, y vars function y1 of -2, I guess it would be minus in this case because I wrote it over here. Well, let's say plus negative, I start with 1, minus vars, y vars function y1 of -2. Oops, sorry. I just want to go down here. And then -2 plus a -1 minus negative 2. So this is just y2 minus y1 over x2 minus x1. I just wrote it in a way that's going to make like it a little bit easier for me to update as I go. So my slope here initially is 2. And then I'm going to then make that h a little bit smaller. And make it a little bit smaller yet. And maybe one more time, make it a little bit smaller yet. What value does it look like this slope is approaching? Looks like negative 1, right? Is everybody okay with what I just did? And basically I'm just computing, I calculated 4 slopes, right, is all I did here. I used my calculator to make it easy on myself, so I didn't have to like grind through a bunch of computation. But that's all I'm basically doing. So what would we say is the instantaneous rate of change for this function at x equals negative 2? We'd say it looks like it should be negative 1. So what is this process called that we just did where we had the 2 points getting closer and closer together, but not ever actually getting there? This is basically a limit as that value for h is approaching 0. And I guess these were all negatives. So our instantaneous rate of change formula is this. Now notice in the denominator, like, those guys can cancel out. You can just leave an h down there if you like. What is this formula though, really? Still just slope, right? It's y2 minus y1 over x2 minus x1. It's that formula where the distance between x1 and x1 and x2 are getting arbitrarily small. That they're basically, as they're going to become the same point. Okay. Now, hang with me here, because when we actually do these calculations for instantaneous rate of change, we're not going to be doing this. This is just a step along the process to get to the shortcut, okay, which is what you'll be using. All right. So if I want the instantaneous rate of change for this, f of x equals x squared minus 1 at x equals 0. Now this says at x equals 0, so instead of x's, I'm going to put zeros in. Everybody okay there? So to simplify this a little bit, because remember, f of x is x squared minus 1, right? So we can do that. Is everybody okay there? So that just becomes h squared minus 1 minus a negative 1. Everybody good there? What do you notice is happening? Negative 1 and positive 1 can add to give you 0, right? And what's h squared divided by h? That just simplifies down to h. And what is the limit as h approaches 0 of h gotta be? What's h approaching? 0. What am I taking the limit of? H. So what is h going to? 0, right? It says it right there. Oh, okay. Now, we're going to now define a new operation. This new operation is called the derivative. So there's two types of derivatives we'll take. We're going to take a general derivative, and we'll take a specific derivative. So we can take the derivative of a function at a point. The answer to that is a number. Or you can just take the derivative of a function in general. The result of the derivative of a function is another function. Okay? Now, if we're taking the derivative of a function at a point, at a specific value, that specific value for the derivative will be the same as the instantaneous rate of change, which is the same as the slope of the tangent line to the function. They're all talking about doing the exact same thing. Okay? Now, if I take the derivative of the function generally, the new function I get back is a slope function, where for any value of x I plug into that, it gives me the slope of the original function at that specific value for x. So these are all equivalent statements. So my derivative, which we denote as f prime, can tell us where f is increasing or decreasing. How do I know when a function is increasing? Its slope is positive. When is a function decreasing? When its slope is negative. So if my derivative function, my f prime, is telling me the values of the slope for the function is increasing when f prime is positive, and the function is decreasing when f prime is negative, because f prime is just telling me about the slopes for f. Okay? So if you remember maxes and mins, when does a maximum occur? When a function changes from increasing to decreasing. What will the slope of the function be at a maximum? If I draw a tangent line there, it's going to be horizontal, so the slope should be 0, right? And the same thing for a minimum, except you're changing from decreasing to increasing. So that derivative function is going to allow me to find those potential extrema. I can set my derivative equal to 0. I can find what are called critical values. the x's where the derivative is 0, because those are my candidates for where my function finds a maximum or minimum. And then I can check if it's a maximum or minimum by making a sign diagram and looking at what is the derivative doing. Is it positive or negative before? And is it positive or negative after? And then I can tell if it's a maximum or minimum or neither. Right? Because you can have a function that has, that has a 0 slope somewhere, but isn't an extrema, right? Like the graph of the cube root of x, of x cubed, where it's like up, flattens out, and then goes up again. It doesn't actually reach a maximum or minimum. The second derivative can tell us about the concavity. So if I take the derivative of the derivative, that new function is the second derivative, f double, we denote as f with 2 primes on it. That can tell us about the concavity. So you remember concavity is like how the graph bends, right? So like a parabola that opens down is concave down, because if you pour water on it, all the water runs out. It's like a roof. That's concave down. Or a parabola with a positive leading coefficient that opens up is concave up, because if you pour water in it, it would catch the water in there. Now some functions, like some polynomial functions, change their concavities from concave up to concave down during the function, right? I can use the second derivative to check for concavity. Essentially, if the second derivative is positive, that means we're going to be concave up. If the second derivative is negative, we're going to be concave down. And then often interesting to us is where the graph changes concavity. That's called an inflection point. To find that, I can just take my second derivative and set it equal to 0. Right? Because if concave up is positive and concave down is negative, then the transition between them has to occur when we cross the x-axis at 0. So the derivatives of a function can tell us a lot, right? We can glean a lot of information that before we could only get consistently by using our graphing calculator, right? How did we find maxes and mins in pre-calculus last year? You had to graph the function, use the min-max command on here. No longer necessary. We can do this using calculus, but we need to talk about how to actually find this derivative in a systematic way or formulaic way, because what we just did before with the limit stuff is like harder than it needs to be. Okay, so I'm missing a page, I feel like, so we'll just do it right now. Okay. So, notation. We need a symbol that says, like, I'm going to take the derivative of something. Just like we need a symbol that says, like, I'm going to add two somethings together. If I'm going to take the square root of something, we need a symbol for this. The symbol that we use is the fraction d over dx. So if I take the derivative of the sum or difference of two functions, I can distribute that derivative operation . Is everybody okay with that idea? If I have the derivative of some constant times a function, I can ignore the constant, kind of pull it out to the front, and just take the derivative of the remaining and multiply the constant on after. And then we have the derivative of a constant is always 0. And then what will be your best friend here is that the derivative of a monomial is equal to n times the monomial to the power of 1 less. And this is true for all of these where the power is not -1. This guy is your best friend. This is your shortcut that allow us to do most problems instantaneously. So let's look at a couple of examples here to practice using these rules. So notice that this function can be thought of as the sum and difference of 3 different functions, right? Everybody see that? So what I can do then is I can look at the derivative of each of these separately. Everybody okay there? And I notice on this middle and last piece, I have a constant of 3, right? So I can take those constants of 3 and kind of pull those to the front. Do you feel okay there? And now, to take the derivative of x squared, I'm just going to use this power rule. So it says I should get the exponent, so 2, times x to the exponent minus 1. Everybody's okay there? Now, can I use the power rule on the square root of x? Can I rewrite the square root of x as x to some power?
Yeah.
Yes. What is it? How would I do that?
X of 1/2.
Correct. So remember that every radical you can rewrite as a fractional exponent. So this is really x to the 1/2. So I'm going to have 3 times 1/2 times x to the 1/2 minus 1. Everybody's okay there? All right. Can I rewrite, or can I do the power rule on 1 over x squared? No, because the x is in the denominator. But can I rewrite 1 over x squared as x to some power? Yes. How do I do that?
You have to bring x squared to the top.
Yeah. Oh, minus 2.
Just use a negative exponent, right? So that's going to be negative 2x to the negative 2 minus 1. And so when I simplify, I have 2x minus 3 over 2, x to the negative 1/2, minus 6x to the negative 3. How do you guys feel? Probably confused. We'll do some more on this next time. Don't worry about the homework yet. Sound good?
Yeah.
That was about 2 weeks of calculus we crammed into one period.